Good afternoon, everybody. Welcome to my presentation on Industry 5.0 creative people, collaborative robots, and smart factories. This presentation is more about where is the industry going in terms of advanced manufacturing and what are the different concepts, whether this is around circular economy, Industry 4.0, 5.0, X.0, how are these all related and what are we trying to drive as we advance in our manufacturing processes. So, a quick introduction from my side. I'm the director for digital enterprise based in Toronto for Siemens. I've been working with Siemens for more than 8 years, primarily on digital and business transformation. My technological focus areas are around advanced automation, digital twins, IoT, artificial intelligence, cybersecurity, and digital service innovations. We have more than 50 product lines in Siemens, which primarily focus towards digital transformations of the industry. I'd like to give you a picture at first, and that picture is about explosion of complexity. In our day-to-day lives, in our personal, professional lives, you see a lot of information nowadays. And you not only see information, you see a lot of technological advancements, you see a lot of changes happening, and that is all creating a sense of little bit the anxiety, but also the complexity that it brings with each of these topics. And what my objective throughout this presentation would be is to little bit solve that complexity or make it easier for all of us to see how we go about changing the way we do advanced manufacturing. Let me first start with an inspiration, and that inspiration is around circular economy. When I talk about circular economy, it has a lot of emphasis towards waste and waste reduction for that matter. And it is also about increased transparency across our value chain or supply chain. And as you can see from this picture that I've utilized with from my friends from Deloitte, really it's about making everything in a closed loop value chain so that there are regenerative natural systems and we don't leave anything for waste. The key benefits for this is that as manufacturers we are able to cut costs, reduce energy consumptions, but at the same time we are able to contribute to society, we are able to contribute to sustainability. And that's really the goal and the inspiration behind it, because it helps everyone in this ecosystem as a challenge for technological organization as well as social innovation. All of this will drive better productivity. Now, I want a little bit focus towards Industry 5.0 as a concept. Are we there yet? What is Industry X.0? I'll take a little bit help from my friends at Accenture, and they've also a little bit looked into these concepts and tried to identify what is Industry X.0. This is again across the value chain of your manufacturing, whether this is product design, production engineering, production systems altogether, or the complete operation. And the key focus there is the collaboration between man and machine. Technology is supposed to be complementary to humans so that humans basically have a better role. There's a higher degree of individualization expected from our customers, and that's where the industry 5.0 would really help, because it will it will merge together the collaboration between man and machine. Now, I want to take you through the next concept, and that concept is the Industry 4.0 concept. And now you may say, why 5.0 and now 4.0? The difference really is whereas 5.0 focuses more towards humans, Industry 4.0, when it was established, it was focusing towards technology and smart systems that drive the future of manufacturing. And with this representation, as you see on the screen, I want to a little bit discuss how this industry 4.0 has evolved, or how the regenerations of different generations of industry transformations have evolved. The first one is really the fixed and the manual processing. We all know this. Anyone in the manufacturing process know that this is how manufacturing really was transforming prior to the third industrial revolution, right? And everything was very fixed, everything was very manual. Even now in some countries we see the same processes happening. This is little bit transformed to the flexible and manual processes now, and that's where things like engineer to order come into play, where you are like basically looking into a combination of our PLM landscape and our manufacturing execution landscape. When I talk about fixed and automated, that's where the concepts of automation are implemented. So, with the third industrial revolution and the fourth industrial revolution, you will see that there is a higher degree of focus on automation, and hence, whatever products, number of SKUs you want to produce, you're looking into automating your shop floor. Where does Industry 4.0 come into play? Industry 4.0 really comes into play when we talk about flexible and automation, or flexible and autonomous, so that the product which we are trying to make, and it could be an individual product as well, which we are trying to make for a customer, can speak to the production floor. All the machinery, all the humans who want to basically manufacture that product, that and we also refer to that sometimes as cyber physical systems, that the product and these manufacturing systems can speak to each other, and they by themselves are looking into how do we go about producing or making a product which is then consumed by our customers eventually. That was really the goal of Industry 4.0. So if you see, these concepts are very similar, but the focus of each of these concepts are different. Whereas circular economy focuses towards reduction of waste, where and Industry 5.0 focuses towards human. Industry 4.0 was, when it was established, was focusing towards more around technology. But all of these are great concepts, right? But we have to understand, why do we do this? Why bother? Why try to understand what each of this concept is? Actually, you have to look at our customers. You have to look at the customers. Customers are the key in driving this demand for the businesses. Whether this is around better time to market, so they look for faster speed, whether this is about flexibility, because now everyone wants an individual product or individualized product, whether it's about enhancing quality, you, me, everyone wants better quality products every day, or it's about increasing the efficiency and productivity. These are key business drivers, and all these different concepts which we just discussed are actually linked to these business drivers, because everyone wants to attain this business these drivers, whether you are part as a technology provider, or you are a manufacturer of certain product, right? Along with this, we want to gain environmental efficiency and ensure the health, safety, and security of our employees, of our assets. That is where also cybersecurity comes into play. But with the advancement of technology, you would also see new business models emerging, as you would have seen that in the consumer space, for example, with Uber and other such models, where uh, things have completely evolved and changed from the way we used to do it. So customers is the central to challenging this manufacturing ecosystem and placing higher demands on improving the productivity. They look for individual product, they look for faster delivery, they look for better quality, or actually the best quality. They look for sustainable products, and even want to know how healthy the products are. Where are the different elements of the product originating from? So all these demands which the customer is placing on the manufacturers today will drive all these different concepts together. So now the biggest question is, we know why these concepts are emerging, and we know what these concepts focus towards, but how do we actually do it? What is the methods? How do we go about it? And is it already being implemented? Are there use cases for that? That's the key question that we have. So in that scenario, I look at technology, and we just cannot throw technology at all these manufacturing processes. And for example, really computers have been part of our ecosystem since the 1960s even, right? But really, the value of using computer or IT assets for that matter really enhanced in the mid 90s, when the complete ecosystem around IT developed. And that's where you saw that the value or the return on investment on IT systems really changed. And by the way, this is not a new thing. Even when you look at electricity, until and unless we build the power grids of the future, electricity really didn't take off. And the same goes for cars, as an example. The cars didn't transform the society unless and until the highways were built. So all of this are linked and part of an ecosystem. Similarly, now, it isn't just about software, because a lot of people think, oh, we have a change in this scenario on manufacturing, and it's about software now. We don't need to focus on anything else and get the software implemented. Actually, I disagree. It's not only about the software, it's about integration. It's about how do you utilize that software across the value chain, whereas we are also trying to develop the processes in the real world and actually implementing that on our shop floor and within our complete supply chain and the manufacturing value chain. So, really, when you look at all these concepts on industry 4.0, 5.0, circular economy, it has to start with integration. And that integration will happen when we are able to combine the virtual world with the real world. In the virtual world, you can realize and optimize things, you can visualize that, you can see the transparency. And in the real world is where the performance really starts to happen on your shop floor, because you still need to automate them, and you need to make sure that that automation is driving the speed, flexibility, quality, and so on, as we discuss from our customer demands. So I little bit elaborate that concept across what we call as the digital enterprise, and that's where the continuous optimization of the most holistic digital twins come into play. And we have three digital twins across this value chain. I first start with the digital twin of the product very quickly. This is where the CAD/CAM systems or solutions come into play to design a particular product, but not only design the product but simulate the physical behaviors of the product, the acoustics, and so on, in order to ensure that the product is what it would be in real life. So you don't need to build costly physical prototypes anymore. You can do the design and the simulation of how the product would behave in the virtual world itself. And that integration really leads to what we call the digital twin of the product. Now, once you've designed your product, you want to know how you want to manufacture it. And that's where the digital twin of the production come into play. So rather than, already starting a plant, you want to design that in the virtual world and see how the plant would operate, and what would be the throughput, how many machinery you would need, how much robots you need. You can even simulate how many people you need in the plant floor. And in that sense, you are able to actually make a virtual representation, test different scenarios of the production environment in the virtual world without laying even a single stone in the real world. And that's the beauty of digitalization. This is actually, I go now a step forward with the automation side, but that's where the digital thread, as I call it, that integration capability would break down. But we have also changed that, we've also challenged that as Siemens, and we have been able to bring forward an integrated approach with the real production environment. And I will give you some examples around that as well, on how virtual production and real production integrate together, so that this digital thread is continuous, and we can ensure with certain concepts that there is real productivity that can happen there. In the real production, of course, you would have to use automation for and robots, and enhance the tools landscape which you can provide to people, so that the real production is driving performance. But finally, also that your product is produced, and this product is able to also give you feedbacks, which is what will drive the performance of your production, of your design, of your virtual production, so that you can come into a concept of what we called as a closed loop manufacturing environment. So really, when you look at a holistic picture of a manufacturing optimization, you have to look end to end across the value chain, right from the product design all the way to the real product. And this is what is enabled with the utilization of technology, with the merging of the real world with the virtual world. All of this has to be protected with industrial cybersecurity as well, because the more you digitalize, you have to ensure that the security aspects are also taken care of. Also, in the real production environment and the real product environment, there would be utilization of things like IoT, which will produce a massive amount of data, and that's what we call as big data, which can be used in order to make better decisions. That's the overall concept of digital enterprise, which, at least from our side as Siemens, we implement with our customers across the different industries. I want to give you now, beyond the concept, actual use cases, and show you some examples of how this has been done. So the first is basically the process simulation. Here you see, in terms of the process simulation, that you can simulate the process. And here a robot is picking and placing certain items which need to be produced. But if I just a little bit fast forward, you can see how humans are working in the same manufacturing environment. And with the simulation that you have done in advance, you can actually see whether the manufacturing environment or the process environment that you created, is it best suited for humans, because there are things like ergonomics and others that you want to ensure for the health and safety of your employees. This, by the way, can also be used for training purpose, and you can now adjust your processes in order for it to suit better to human needs. You can also simulate the complete factory environment. So it's not only about a process simulation, but the entire factory. And as I was explaining before, you can plan your complete production. You can see how much machinery, robotics you need, what do humans need to do, and how do they need to work in that environment. And you can even plan your throughput out of that. That's the best part of using simulation technology uh, in and as software, which would enable digitalization. But I promised you that I will show you how the integration also happens. So on the left hand side, you see that we built a simulation. So a real plant, a real process is not yet done, but we have built a simulation into the virtual world, and we have virtually connected it to a digital twin of our controller, the automation equipment that you use in order to control the entire automation landscape, or the OT landscape, as we call it. And here, once the automation code is written, you can run that in conjunction with the simulation, and see whether the automation code would actually work to the process as you have defined for the different parameters that you want to achieve for this process. This is the beauty of digitalization, because you can merge now the real world with the virtual world. And what happens with this is, you don't have to commission anything now at physically at site. You can actually demonstrate that in the virtual world, which is where the beauty of virtual commissioning, as we call it, comes into play, because you can now do even things like factory acceptance tests virtually by using these concepts. I will talk a little bit about artificial intelligence as an example, and how that comes to the shop floor. You must have heard of a lot of examples of how AI is being used in the IoT space. But how do we bring artificial intelligence to the shop floor? We do that by introducing what we call an AI module in our controllers itself, which work in conjunction with the robot and the camera, where the camera is capturing the different grasping points of a particular object. And using neural networks, we are evaluating what is the best grasping point for a particular object for for that robot. And all of this is happening right at the shop floor. So AI is happening right at the shop floor at the controller level itself. And that's the advancement in technology which is happening. So you see, the best grasping points has been determined, and that goes as a decision making to the robot so that the robot can make the right decisions. Another example, and another technology for that matter, is augmented reality, right? Augmented reality is something which we want to enhance and support the way we want to little bit look at our machine and how do we want to maintain it. So rather than having a lot of different prototypes on what are the different machine parameters and having that in different dashboards and systems somewhat separately, I could sit at my home, and if my machine is running in my factory, I can put on my glasses and see everything, all the different parameters of my machine, so that I can see whether my machine needs any support. And that's where the beauty of augmented reality comes into play, because you can now make faster decisions. You can even work remotely, and even for service capability for that matter, you can even look into troubleshooting a particular machinery in case something is going wrong. And that's the value of digitalization as well. I now change gears to the hot topic of IoT. And IoT is very special because cloud and IoT is in a way driving, this fourth industrial revolution, because it also connects the different data points and gives transparency so that better decision making can be done. And I use an example from our factory at Siemens Amberg, which is the PCB cutting machine, where we are evaluating the speed and the current of this machine, because there used to be problems in when aggressive milling would cause the drive bearing to get stuck. So we wanted to identify why is this happening, how do we solve it, and we wanted to introduce concepts such as predictive maintenance. Right? We The entire IoT concept is built with two levels really. One is the production critical level, and second is the non-production critical level. So we deployed an AI algorithm on the cloud, and we looked at the data which we had traditionally captured from the PCB cutting machine, and we did some data analytics and tried to identify why is this happening, and what are the different parameters in order to make a prediction for the failure of the PCB cutting machine. We brought that AI algorithm for anomaly detection and for predictive maintenance onto the edge level, which is where the production critical level happens. So that decision making now, in terms of knowing and understanding why the PCB cutting machine failed, is all happening right at the edge of the application. So, right at the edge of where the PCB cutting machine is running. So, this combination of edge and cloud gives the best possible way in which we can ensure that our assets are best utilized, as well as making sure that we can use predictive maintenance to much more efficacy and not load all the data onto the cloud and really increase our costs there. By the way, the combination of edge and cloud is not something which is what we as Siemens is driving. Even all the cloud companies have realized the issues which we sometimes face with cloud, and also the concepts between what we can do at edge level and at cloud level. So MindSphere is our cloud platform, and Semantic Edge is our edge platform here. Everything would be great, but these technologies, we still need to ensure that we integrate them more and more. And this is where the concept of closed loop manufacturing comes into play, because with closed loop manufacturing, we are able to combine the physics based analytics with the data based analytics. So, whatever you have simulated in different scenarios based on your knowledge and so on, you want to test them with real data. And that is where whatever you're collecting the data on MindSphere or at edge level, you want to give that as a feedback to this physical simulation, so that you can improve upon what you had planned and then make changes accordingly, and also see what change you made, how does it impact your production. This closed loop manufacturing with the click of a button creates a lot of productivity for you, because you're not now able to put actionable insights into play, right? So that you make your production systems much better. And that's the beauty of closed loop manufacturing from Siemens. So, in conclusion, I must say I've given you a lot of view on technology. I've given you a lot of view on the different concepts, and also on the use cases which have been driving across the manufacturing landscape. Because we have to remember that change is something which is inevitable, and to survive in this disruption and this digital era, all incumbents, all manufacturing enterprises need to rethink every element of their business and transform themselves into a digital enterprise. So it's not only about product design, it's not only about your IoT technology, it's not only about your shop floor automation. You have to look at every aspect, and you have to think, and how do you integrate this all together. With that thought, I leave I leave it I leave you with the we leave you with the thought that this digital future starts actually today, because digitalization has already started. Thank you very much, and I look forward to your questions and having an interaction with you. And if you want to reach out to me, please feel free to do so, and I will definitely share some of my thoughts more on these advanced technologies and these different concepts and how they're progressing. Thank you very much for your time.